I'm going to talk about the last word problem here first. Okay, studying parabolas is actually very studied in physics, real life, projectile objects, architecture, a lot of sports analysis with how to project a football, a basketball, whatever. So this is the shape it makes. So think about somebody that is hitting a golf ball off of a hill or throwing a football from their hand. Okay, what's happening? So if I say, what does the y-intercept represent? If you're thinking about whatever is happening, if this is somebody hitting a golf ball off of a hill or somebody throwing a baseball or something, what does the y-intercept represent? So this is the time of the event and this is the height of the event. What's the time specifically here? 0. So if the time is 0, what is this all about right here? It's the starting height. So the y-intercept would be your starting height. Because that's what is where you are when the time is 0. That's what's happening. Okay, now let's talk about the vertex in this context. So again, you got that ball in your head. It was projected. It's going up. The vertex. What does the x part of the vertex represent? What does the y part of this vertex coordinate? So pretending it is 3, 200. What does 3 what? 200 what? What would the 3 be in this context? 3 seconds or whatever, right? 200 feet. So the x would be the time to get to the highest. The how long does it take you to get up to the top? And what would the 200 in this context be? The y part of this would be the highest height. The time and the height. Separate those two ideas. How long does it take to get there and what is the highest? And what does the x-intercept mean? So think about that ball. We threw it, it went up, it fell, and then what happened right here? It stopped because it did what? Hit the ground. Because what is the y here? 0. The height is 0. So therefore it's hitting the ground. So if this was the number 7, what does it mean? It took 7 seconds for that ball to travel and end. It hit the ground. So time to hit the ground. Where y equals 0. So that's the time it will take to travel and then hit the ground. Okay? That question is on your test, and I don't want any number values. I'm looking for an explanation. Okay? What is the y-intercept in words? What does it even mean? Okay, number 3. We're going to work backwards on these questions. A frog is sitting on a rock. Okay, so a frog looks like, how do you draw a frog? I don't know.
That's pretty good.
There's my frog. Sitting on a rock, and it jumps into the air, and it falls, and it lands in a pond. Okay, can you visualize what's happening? The parabola. So we have time in seconds, and we have height in centimeters. And it makes a parabola. How did I know that it looked like that? Because it has a negative multiplier number. So my parabola is shaped downward, right? My parabola is shaped downward. Okay, how long does it take for the frog to reach its max height? What is the highest the frog reaches? So what is all of that? I want to find the vertex, because I'm talking about how long does it take to get to the highest? What is the highest? So I need a vertex. Okay, more and more practice at your homework, you should know how to find the vertex. How do you find a vertex when your equation looks like this? How to find a vertex when your equation looks like that? Negative b over 2a, comma, plug in. That's how you get your vertex, okay? So this was the general form, so vertex, general form, you need to connect that right away. So opposite of b is negative 150. 2 times the a, which is negative 490. Get me a number. That's going to be a really small decimal because I can see the number in the bottom of my fraction is bigger. So if you're worried that your number is wrong, it is a decimal number. Did you remember when you type that you have to do the brackets on the bottom? Can you go to 3 decimal places? It's a small decimal. Can you do it to 3 decimal places? Okay, you have to type it in like this into a calculator with the brackets on the bottom, or else it does not come out right. Is that what we got? 0.153? Okay, now I need you to plug that number in. So you're doing negative 490 times 0.153 squared and did we get a value? Did you get 36.48? Okay, how long does it take? What would you answer to that question? How long does it take the frog to get up to the top? 0.153 seconds. That's how you would have to answer that problem. What is the highest height the frog got to? So 36.48 centimeters. Okay, so those are the answers. So in applied math, we do this kind of stuff. We just type it into here. So you can see my parabola, and I calculated that by just typing in my calculator. Can you find that point for me? So there's the highest point. So it took 0.153 seconds to get there. the y-intercept. What would this mean if I asked you about the y-intercept? 25 what? 25 centimeters is what in this situation? The height of the rock. The frog is right now at the very start, before he does anything, at 25 centimeters, so that's the rock's height. And I could find this coordinate, which is when it splashes in the water. So I'm going to do that. You don't know how to do that yet. We will do that one day. So when does it hit the water? What's going on here? So it took 0.426 seconds, and then it splashed into the water right there. Okay. Let's go to number 1 now. So number 1, you're selling concert tickets for $9 and 200 people come to your concert. So how much money do you make if you were that performer? $9 tickets, 200 people come, $1,800. So does this make sense? The revenue would be the ticket price times the number of people. Is that what you did in your head? You did the ticket price times the people that come, and that's how much money you make? Okay, so I'm going to do this. I'm going to leave 2 brackets that are big right now because I'm going to fill in a bunch of stuff. Okay, the ticket price started at $9, so I'm going to put that at the front of this bracket. And 200 people came. Okay, so reading the next sentence. For every $2 increase, so that would be on your ticket price. So if the ticket price is going to increase 2, then 10 fewer people are going to come to this concert. Okay, this is missing something important, which is a variable, right? So I'm going to put an x because if this goes up by 2 or another 2, I don't really know. I'm trying to say it could go up by 2 or 4 or 6, I don't know. But as this goes up, what has to happen to the 10? It also has to go the same amount. So if this goes up by 4, this would have to go down by 20 and so on. Okay. Anybody see something that we possibly could do that we know how to do in math at this point when something looks like this? Whenever I ask this question, it usually starts with an F word. What do you think? Could I FOIL something that looks like that? Okay, can you get me your FOIL? Multiply that all together. Okay, so all you did right now is that you've developed a quadratic function for this problem. That's what you've done. You've developed your own quadratic equation. So we need to figure out what price should we sell the tickets to maximize your revenue. So what are you looking for to find a max? a vertex. That's what I need. I need the vertex stuff. How do I find vertex when my equation looks like this? Negative b over 2a. All right, how it looks, I've tricked you a little bit. Which is the negative b part? Did you do negative 310? Over 2 times, what is the a number? Negative 20, did you pick that? Did you notice how I didn't have this as an A, B, C order? This is the C, this is the B, and then this is the A. Okay, get me a number on that division. $7.75. Okay, I'm actually not going to plug it in, and that's what we normally do, but we're not. Here's why. If I plug it in to the equation, what is the output? Revenue. But the question doesn't say what's the max revenue, it says what's the ticket price. So if I plug it into this, I would get a number that represents the revenue. If I want the ticket price, I need to plug it into the spot that says what's the ticket price. What's the ticket price? So the tickets were $9 and I added 7.75 times. Okay, does that make sense on where I'm plugging it in? Because I have to think, well, what's my output? You plug in, you get an output. What is your output? So if the question had then said, what is the max revenue? You are plugging it into this line because it equals revenue. Okay, does that make sense on where to plug in? Okay, the last type is a fencing question of a barnyard. We have 240 meters of fence and we need to divide a rectangular pen into 3 areas. As in you need like cows, horses, pigs, whatever separated. So there's my field. So I have 3 areas for animals. Okay, I'm going to label some of these sides of fencing. So this and this I'm going to say is the length of my field. And these sides I'm going to call my width. So I need all of that. I have 240 meters of fencing. So is it okay if I add that all up? So every side added together will make 240 meters. Okay, we are trying to maximize the area of this rectangle. So area of a rectangle, I'm not going to give you this formula, you need to know this formula. How do you find the area of a rectangle? Length times width. Okay, so this is where I want to get a quadratic. Here's my problem. I cannot use this equation when it has 3 variables in it. I can't have an A, an L, and a W. So what we're going to do is we're going to get one variable isolated, and then we're going to replace it into this equation so that I can work with just 2 variables instead of 3. Which letter is easier to get alone, the L or the W? The L is easier because there's more of those. So I'm going to go 2L equals 240 minus 4W. Does that make sense? I moved the W over. This is isolation stuff. And then how else do I get L alone? I would divide by 2. And when I say that, everything gets divided by 2, right? Okay, now this is a math rule. If this equals L, can I replace that L over there with this whole statement? Does that make sense? If L is equal to this, that means it could be substituted in place of L. And now I can see an equation with A's and W's, just 2 variables instead of 3 variables, which is what we've been doing. Okay, now we're at the same point as question 1. What should I do with this stuff? I should multiply it out, not technically foiling, but distributing it. And I have a quadratic equation. Okay, so you have to work to get your equation. Now that I have my equation, my question is what's the max? I'm trying to get to a max area, which means I'm trying to get a max, a vertex. How do we get a vertex when your equation looks like this? You need to do a negative b over 2a. Be careful which is your b, which is your a. Negative 120, that's the b number. 2 times negative 2, right? Because this is not in order. This is a b, this is an a. Okay, so you have to type it in with brackets. And I got 30. Okay, let's talk about what the variables are here. If I plug the 30 into my equation, what will the number that's output get me? It'll tell me the area, the largest area. But I didn't ask you what's the largest area. I said, what's the dimensions? So 30 is the x. What is the Rx in this scenario? 30 is the width. 30 is the width. Because normally it's the x, but we don't have an x, we have a w. So if 30 is the width, what is the length? Can you go back here to find the length? So do you see I'm choosing this equation to plug it in? Because if I chose that one, it would get me an area. If I choose this plug-in, it will get me an L. So you have to understand the input-output situation. Okay, so there's my final answer. The dimensions ended up being 30 meters by 60 meters. Okay, if I did ask you for what is the largest area, you can go with the 30 into this equation. That would give you the area. Okay, that's the only ones you'll see, but on this question, what if I say that you build your pen along a barn? So if you build a rectangular pen and one of the sides is along a barn, you can assume that you don't need to put fence there, right? The barn is your fence line. Okay, so if you're going to build along a barn, there's going to be no fence on the one side. So you might run into something like that.